All right, so today we're going to look at two sections. We're going to look at 1.2 and part of 1.3. Okay, first thing I'm putting up is just kind of some general guidelines when you're trying to solve any kind of problem. It doesn't even have to be a math problem, just the problem-solving process in general. Okay, first thing you really have to do, read the problem, and then figure out what information are they giving me in this problem that I can use, and what information do I need to find. Okay? If you can't figure out what they're asking you, then we're going to have no idea how to even solve it. So we have to know what they want and what they're giving us to help find what they want. Next thing we have to do is figure out some kind of plan for solving the problem. Okay, page 13 in your book lists a bunch of different strategies. Sometimes a picture is helpful. When we do trigonometry, we're going to draw pictures for almost every problem. Okay, a lot of times it'll involve some kind of triangle, things like that. A list could be helpful. Certain problems I think that are helpful to make a list. Let's say I gave you the letters ABC, and I said, what are all the different ways you can write ABC? ABC, ACB, CBA, things like that. A list might be helpful because that's a pretty small number. Now, if I gave you 10 letters and said, tell me every way you can write them, a list is a little too time-consuming. Okay? But a list could be good for some things. Sometimes we're going to have to solve an equation. Okay? And page 13 has got a bunch of other ways and suggestions for how you solve a problem. Once you decide on what kind of method you're going to use to solve it, that's when you actually do it. Okay, so step 3 is when you finally get out your calculator and then you start doing stuff. Steps 1 and 2, you don't really need a calculator to do. All right. Any questions on the 3 steps? Okay, so we'll try applying those 3 steps in this problem. Okay, so there's a company that charges $15 to rent a car, and then they charge 20 cents for every mile you drive. So 15 cents to rent a car, 20 cents a mile. And ultimately, I'm going to end up writing an equation, like y equals, that will give me the cost of renting the car as a function of how many miles I drive it. Okay? How many variables am I going to need here to set up something like that? Marina? 2. Yeah, I'm going to need 2 different variables. Somebody else tell me what one of the variables is going to represent. Orlando?
How many miles you drive?
Right, one variable is going to be how many miles we drive. Okay. What about the other variable? Yep, Nicole?
The cost.
Yeah.
The total cost.
The total cost. Okay, so we'll let y equal the total cost, and we'll let x equal the number of miles that we drive. Okay. And then once we figure out what the model is, we'll use that model to find the cost for 50 miles of driving the car and then 100 miles of driving the car. Okay, this is going to pretty much be like an Algebra 1 type of equation. Anyone think they could tell me what the equation would be? In Algebra 1, I'd lead people through it a little bit more, but I think you guys can probably just give me the final answer right away. Yep?
So y equals 0.20x plus 15.
Perfect. Y equals 0.20x plus 15. Okay, Sylvia, what's the 0.20 in that equation? I mean, it's the cost per mile, but just in terms of that equation, forget the word problem, what is 0.2?
It's how much you pay for extra miles.
Well, it is per mile, but pretend you didn't know this was a word problem. Pretend I just wrote down y equals 0.2x plus 15. And I said, what is 0.2? It's the slope. Exactly, it's the slope. And what about the plus 15?
Y-intercept.
It's the y-intercept. Okay. Very good. So now if we want to use our model to find the cost for 50 miles, how about Carly, where would we plug in 50? Is that x or y?
Y.
Well, remember, y is going to end up being the cost.
Oh, so it'd be the X.
Right, so if we're plugging in miles, that's our X. Okay, so if we want to do that out, 0.20 times 50 plus 15. All right, so we do that. 0.2 times 50 is going to be 10 plus 15, 25. And that was dollars. And you can do the same thing for 100. Okay, plug in 100, multiply by 0.2, and add 15. Okay, so what we just found is what the book is going to call the algebraic representation of that situation. Okay, it's an equation that completely, it's kind of abstract from the actual details of the problem. Y equals 0.2x plus 15. It's just an equation. If you start getting into what the meaning of it is, then we're starting to describe the word problem again. Okay, but the equation itself is the algebraic representation of the problem. Okay, so the next one says, suppose same car company. Sarah was charged $50 to rent the car. How many miles did she drive? How do we figure that out? Now they're giving us a cost and we want to know mileage. Taylor?
How would you plug the $50 into the Y?
Okay, sure. We can do it that way. So an algebraic way to do it is to plug 50 in for Y. And then write the rest of our equation. 0.20x plus 15. Okay, and how would we solve that? How about Josh? How would we solve that?
Subtract 15.
Yep.
Divide 0.2.
Yeah, we'd subtract 15. What's 50 minus 15? 35. And what did you say? Divide by 0.2. Okay, dividing something by 0.2, that's a fifth. So if you divide by a fifth, it's really like multiplying by 5. So 35 divided by 0.2, or if you did it in your head, 175. Okay, and that's the miles. Okay, so that's one way to do it. Okay. Another way to do it is to use more graphical approach, okay, on our calculator. So let me show you how we can do it on here. Okay, what we're going to do is we're going to graph a couple ways to do it. We're going to graph two different equations. I'm going to graph what's on the left-hand side of this equal sign as my first equation. Okay, that's a constant equation. Y equals 50. It's a horizontal line at 50. Okay, on the other side, I'm going to graph 0.2x plus 15. Is everybody able to type that in? Okay, so we're going to have a horizontal line at 50, and then we're going to have a line with a slope of 0.2 and y-intercept of 15. Let's look at my window before I even hit graph. If I hit graph right now, what's going to happen? Based on what I typed in for equations, yeah?
You're not going to see most of it because it's too small.
Yeah, my viewing rectangle is too small. I have a function up at y equals 50. Well, my y max only goes to 12. Okay, so I generally don't like to set the y max exactly what it needs to be. I like to just go a little bit above it. So let's set the y max at 60. Now the x max, normally we wouldn't know, but we already did it algebraically, so we do. We know we're going to have to go out to when x is 175. Okay? If we didn't know that, we might have to use a little trial and error to get the right window. So let's set the x max at 200. Why is it good to keep the x min and y min at 0? Those are pretty good values. Why don't I want to go negative with x and y? Now this ties back into the word problem. Brandon.
She's not going to be paying any negative money if you drive any negative miles.
Right. So when you're looking at a graph on the screen, it depends. Do you want a graph of the real problem, or do you just want an algebraic graph which doesn't take into account the real problem? I kind of want to look at a picture that represents the real problem, so I'm not going to look at negatives. Okay, so there's my two lines. Y equals 50 was the left. 0.2x plus 15, that was on the right. And I want to know where these two lines are equal, algebraically. What does that mean in the picture, where the two lines are equal? What's another way to say that? Shannon? So we normally don't say lines are equal, but we say it's where the two lines meet or intersect. Right? Well, there's a way the calculator can automatically calculate an intersect for us. Okay, so what you're going to do is press second, and then you're going to press calc. Okay, when you do that, you should see that menu. Does anybody not get that menu? Okay, second, calc. Now, if I'm trying to find where the lines cross, which option do you think I'm going to pick? Yeah.
Intersect?
Yeah, intersect. I want to know where they intersect. So I either go down to the fifth option, it's fifth option on my calculator, hit 5. Now what it's going to do is it's going to ask me for a point on the first curve. The calculator calls everything a curve. Doesn't matter where you pick. Point on the second curve somewhere. So you just pick a point anywhere you want, hit enter. And the reason why it asks you for that is because let's say you had 6 lines on the screen. Well, the calculator wouldn't know which 2 you want to find where they cross. We only have 2 on the screen anyway. Okay, but if you had more than 2, you got to tell the calculator which 2 you want to find the intersection for. Okay, and then the guess. The guess isn't overly important. The closer you go to the actual point, the faster it'll tell you the answer. So I hit enter. Tells me the answer pretty quickly. When x is 175, the cost is $50. Okay, so that's a graphical approach to doing it rather than algebraic. Any questions on how we did that? I'd say in this case the algebra is probably faster than the graphical approach, but if I gave you very complex equations that curved, all kinds of things, this might be a better approach, and it might be our only approach. Okay, when you're doing the homework, a lot of times you're going to see directions that say find a complete graph. Okay, when you have a viewing rectangle that shows all the important features you need to see, that's called a complete graph. So there's no one right answer for what your window should be. Okay, if you're graphing a line that's not horizontal or vertical, I would say making sure you can see the x and the y-intercept. That's important. If you're graphing a parabola, I would say it's important that you either can see the minimum or you can see the maximum. Okay, if you graph a parabola and you cut the min or maximum off the screen, that's not a complete graph. You're not showing me all the important features of the graph. Anybody have any question on what I mean by a complete graph? So all you'd have to do is write down your window. Tell me x min and max. Tell me y min and max. All right. Let's try it here. It says to graph y equals x squared plus 10 and find a complete graph. All right. Well, first thing I want to do, I want to clear out everything we had in there before. And I want to set the screen back to the original zoom. So I'm going to go zoom 6. First thing that does is it sets my window from -10 to 10, -10 to 10. Next thing I'm going to do is just clear all the equations I typed in. All right, now I'm going to type in the one that they have here. So x squared plus 10. I'm going to hit, well, before I hit graph, what's the shape of this again? Has an exponent of 2 as its highest exponent. So that makes it what kind of shape? Oh, Justin? No, it's not going to be an oval. It is a function. An oval would fail the vertical line test. So this is a function. What's this shape, Marina? This is a parabola. Okay, anything that has an exponent of 2 as its highest exponent in that form is a parabola. Okay, so I hit graph. Something's not right. So I typed in the equation right. If I didn't, it would have said error. What's wrong here? Yeah, Michael.
You can't see the line. It's out of the graph.
Yeah, you can't see that parabola because it's not on the screen. Where is it? Is it above, below, left, right?
Above.
It's above it. I think when x is 0, your y value is 10, and the values only get bigger from there. Okay. So, Michael, what do I need to fix?
You need to increase the maximum y value.
Yeah, what would be a good value?
20.
Sure. 20 is fine. I would say that's a complete graph. It's a parabola. I know it's not going to turn back down again somewhere way off the screen. It can't. It's a parabola. And you're looking at the minimum. You might have noticed when we went to second calc, there was a thing here called minimum. And this does what you would expect. It calculates the lowest point between 2 points that you tell it. So you can use that to actually find the coordinates of the minimum. In this case, we already know it. It's 0, 10. That's the minimum. Would this have a maximum? This parabola? No. To have a maximum, it has to look more like this. It has to be flipped over. That has a maximum. This one has a minimum. Okay, so that curve, as we already mentioned, that's called a parabola. Okay, and the one that I showed you is a more simple form of this general equation here. In my case, I let C be 10, and I let B come out to 0. And I let A be 1. But y equals ax squared plus bx plus c. That's the general form of a quadratic equation. If you pick any real number for a, b, and c, it will always look like a parabola. As long as you don't let a be 0. If you let a be 0, then you just wiped out the x squared term. It's gone. So as long as a is at least a 1, or not 0, you'll get a parabola. Okay, let's try this one. Okay, it's y equals the square root of x plus 20. This one's a little bit different. What do you have to be careful about when you take a square root? Okay, in the other problem, all we did was square a number. There's nothing to really be careful about when you square something. You can square negatives, you can square positives, you can square fractions, 0. But not with a square root. You can't just do anything you want. We have to be careful of. Yeah?
You have to make sure you put parentheses around the x plus 20 because otherwise it's just going to square root x and then add 20 to that.
Okay, that is something else that's important. On the TI-83, it's automatically going to insert a parenthesis for me. Okay? On the TI-82, it won't. So if you're using the 82, you're going to have to type the square root and then put a parenthesis. Just like that. Okay, so that's important. What else is important with square roots? What else do we have to be very careful about? Assuming we're working with real numbers, not imaginary. Yeah, Michael.
Make sure you don't get the square root of a negative.
Right. We have to make sure we're not going to end up taking the square root of a negative. What does that mean about x here then? Can you give me some kind of restriction on what x would have to be to make sure what you said never happens?
It's greater than negative
Exactly. Greater than or equal, because you can take the square root of 0. That's okay. But x can never, it has to be greater than or equal to negative 20. If x is negative 21, we're going to have a problem. Okay? So that gives me an idea of what I need to set my window at. Okay? I'm going to go to negative 25 on the x-axis. Let's just try that, see if we get a good picture. Yeah, that's good. It's basically like half of a parabola on its side. Okay? That's the square root function. It always has that kind of curve to it, going up very slowly as x heads towards infinity. Okay? So for a complete window, what I would do on your paper is write down exactly what you have right there. And you can write it if you want. Negative 25 to 10 by negative 10 to 20. Not the only right answer, but that is one. All right, so next thing we're going to look at is how we can graph some data points on the calculator. Almost like making a scatter plot. Okay, we won't use this a lot, but we will use it a little bit. Okay, so let me show you how you type these in. The first thing I'm going to do is just get rid of anything else I typed in so it doesn't mess with what I'm going to do right now. Okay, what I want you to do is press the stat button. Okay, on my calculator it's right near the arrows. So press stat. And next you're going to go to edit. Edit's the first choice. Okay, if you already have some numbers typed in there, let's say you got the calculator and somebody already typed stuff in, you just go up to the number, press delete, and that'll get rid of the numbers. Be careful if you go to L1 and hit delete. If you do that, it deletes the whole list, and then we have to reset the calculator to get it back. That's kind of a pain. Okay, so just press your stat button, go to edit. L1 are your x values. So what we're going to do is type in all the x's in L1. And then we'll type all the y's in L2. So just type in that list that you see. It's pretty symmetrical. So we have -3, -2, -1. I like to do all the x's first because it just keeps going down that column when you hit enter. 0, 1, 2, 3. And now type in your y values. So if you just hit your right arrow, it'll go back over to L2. Type in -18, -2, 2, 0. You just keep hitting enter each time. -2, 2, and I think it's 18 again. Yeah. Based on the symmetry here, 3 is 18, -3 is 18. 1 is -2, -1 is 2. So there's a bit of symmetry going on. I'm sorry, 1 is -2, -2 is also -2. So that might kind of suggest the shape that you're going to end up seeing, some repeated y values. Okay. Is everyone able to type those in? Okay, that's the long part. Now what we're going to do is press y equals, okay? And we've got to go up to one of our stat plots. Okay, the plot is the thing that shows the numbers you typed in. So I'm going to go up to plot 1, and notice when I hit enter, now it's highlighted. What it just did was turn it on. Okay, if the last person that used the calculator left, plot 2 and 3 on, if you want to turn it off, you just go to it, hit enter. That will turn the plot off. Okay? And again, if you forget any of these steps or you need to go back, you can always go online and bless you, see the steps right there too. Yeah.
In step 2, it says press second.
Oh, second quit. I'm sorry. When you're Once you're typing in all the numbers, if you want to quit, you can quit and just go back to the main screen. It's not necessary. It's just, if you start pressing other buttons right now, the -18 is highlighted. Be careful you don't accidentally delete it. So if you press second quit, now you're safe. You can't mess up your list. Okay? Then you can press Y equals, turn your stat plot on. Okay? Yeah?
What happens if you don't see like plot 1 or plot 2 if the second one?
Anybody else that didn't see plot 1? Plot 2? Let's take a look. So if you're on, okay, the TI-82, a little bit different. Let me show you on that one. Okay, so on the TI-82, stat plot is actually above Y equals. So if you go second stat plot, there's the 3 plots I was looking at on the TI-83. Just pick plot 1. Okay, if you pick plot 1 and you hit enter, then you have the choice to turn it on or off. Okay, so it's a good question. It is a little bit different on the TI-82. Okay, so on the TI-82, hit on. I have to go back to the 83 because that's where all my data is typed in. Anybody that has the 82 and had trouble, but now they got it? All right, so you got your stat plot turned on. Okay, I'm going to go back to my 83 plus. Okay. Oops. Now the last thing we just have to do is set our window and graph it. All right, looking at my x's, my smallest x value was, let's see, -3. My largest x value is +3. I'd set a window -5 to 5. That's good for your x's. How about for my y's? Look at the smallest y value, look at the largest y value. What would be a good y min and y max for my window here? Yeah, I'd go -20 and 20. Don't go right to -18 because you might not see it. It could be on the edge of the screen. So you got your window, -5 to 5, and -20 to 20. Okay, so set your window and press graph. Okay, and what we're looking at is the individual data points we just typed in. This is more of a, this is not a parabola. This is more of a cubic equation because it would turn twice. Okay. Any questions on that? Yeah?
Mine says window right
Okay. And did you type in exactly those numbers? If usually when you have window range, it's because your minimum is bigger than your maximum, or your maximum is smaller than your minimum. All right. So if I tried to make my maximum -7, it says error window range. Can't have my maximum smaller than my minimum. Okay. Any questions on that? Now what we can do, and we're not going to get into it today, but we can have the calculator tell us what is the equation that would go through those points, even if we don't know it. Okay? The calculator can figure it out. I'll show it to you. That's the equation. It's y equals x cubed, no x squared term, minus 3x. That's it. It's x cubed minus 3x. So if I type that in, and again, just watch this step. That's the exact equation that goes right through those points. Right, so if we have a set of data, we can use the calculator to predict a model for it. Okay, we'll do that more later on, but I just want you to understand how to type the points in. I jumped ahead a little bit. So my next question was going to be, show that x cubed minus 3x is a model. Well, the way you'd show it is you'd type it in, because I gave it to you. I wouldn't expect you to calculate it. And you look at it and you say, oh, it looks like it goes through all the points pretty well. that's a good model for the data. So now we could use that model to predict, what if x is 7? What would the y value be? Well, now that you have the equation for it, just plug in 7 for x, see what you get for y. You could do it by hand for now, or I'll show you a way eventually you can use this table, and it will list a bunch of values. And once I show you how to set it up, you can type in any value you want for x, and it'll automatically tell you y right away. Okay, so it's pretty handy. Okay, any question on example 6? Okay. All right, so that's it for 1.2. And we're going to finish up with part of 1.3, talking about what a function is. So you're familiar with domain and range, vertical line test. That's the kind of stuff we're going to look at right now. So in the example that we did from 1.2, okay, we didn't call them this, but x is your input. It's also called your domain. It's also the independent variable. And your y, that's your output. Okay, that's your range. That's your dependent variable. Okay, sometimes people have a little trouble figuring out what's independent and what's dependent. And what I usually do is I just read the word problem 2 different ways and figure out which way makes more sense. So I could say, does the number of miles I drive depend on the cost? Or does the cost to rent the car depend on how many miles I drive? It's the second way. The cost is dependent on how many miles I drive. Cost is dependent. That's why cost was my y value. So that's how I figure out which one is independent and which one is dependent if I get confused. If you had a problem that said somebody makes a certain amount of money depending on how many hours they work, okay? Well, you'd say, okay, does how much money they make depend on how many hours they work? Or does how many hours they work depend on how much money they make? I think it's the first way. Okay? How much money they make is dependent on their hours. Okay. Any question on that idea? Independent, dependent variable? Okay. So a function is basically an algebraic equation where every time you plug in an x value, any x value, you only get one y value. Okay, so a function is an algebraic equation. When you plug in an x value, there is exactly one y value that you get. Another way to say that is y is the image of x under f. So the value that you get is the image of x under f. Okay, I don't usually say it that way, but it's in your book, so if you see it, you know what it means. Okay, something that's not a function would be this. This is not a function. Because when I plug in an x value, I get 2 y values. If I plug in 16 for x, I get 4 for y, and I get -4 for y. That does not have exactly one output. That is not a function. Take away the negative symbol, then it is a function. Or take away the positive symbol, and it's also a function. Okay, so kind of just summarizing the same thing different ways. The domain, that's your set of inputs. It's what you're allowed to plug in. Okay, when we had that square root function earlier, Michael told us that x had a restriction on it because of the square root function. X had to be greater than or equal to -20. That was the domain for that function. All x values that were greater than or equal to -20. The range, those are the outputs. If you're looking at it on a graphing calculator, the domain you can look at is basically how far does your graph go left to right. Okay? That has to do with the domain. How far does your graph go up and down? That has to do with the range. So if we look at a picture like this, that graph is going to go left and right forever. Okay? This part on the left is just going to keep going. It's mostly going down, but it is still going to the left. And the part on the right, it's going up, but it's still going to the right. So this graph has a domain of negative infinity to infinity. It's just going to keep going left and right forever. It's also going to keep going up and down forever. It's never going to stop. How about a parabola? Does a parabola go up and down forever? No. Parabola has that U shape, or it has more of an N shape. So parabolas are a little different. Okay? But that's the idea of domain and range. Okay, unless otherwise stated, the domain has to be a real number. And there's two different ways you can write a function. You can use y equals notation, or you can use f of x. We'll see a lot of the f of x notation in our book. How many people have seen that second notation before? Pretty much everybody, yeah. And it doesn't have to be an x. Sometimes it's a g, sometimes it's an h. It's convenient because if you have multiple equations, it gives us a way to name them. Equation f, equation g, equation h, versus just having them all start with y. Right, so two different notations for a function. And again, pronounced f of x. Okay, we already found a complete graph for a square root function before, so I'm not going to go through that again. But I do want to at least try to figure out what the domain and range would be. What's my restriction on x here? So you have to think about square roots. Think about what you're not allowed to do. And tell me which values of x would make it so that would never happen. Yep.
Greater than greater than or equal to 3.
Yeah. So there's a couple ways you can write it. If you want to write it as an interval, the bracket means greater than or equal to. Remember, parenthesis is what you use for greater than. To infinity. Now, I can't put a bracket on infinity because a bracket actually means I can reach that number. I can be equal to it. Well, I can never reach infinity. It just keeps going. All right? So that's one way to write your domain. Or you could write all x is greater than or equal to 3. Okay, let's take a look at the range. So square root of x minus 3. I'm going to turn my scatter plot off because I don't need that anymore. Start with zoom 6. What does it look like with the range? What's the lowest value that it ever hits on the y-axis? Oh, Nick?
0.
Yeah, 0. It starts right on the x-axis. Okay, that's 0 on the y. So it starts, and how high is the square root function going to go?
It's going to be infinite.
Yeah, infinite. It's not going up very quickly, but very slowly it will keep going up. So the range here is 0 to infinity. Does it reach 0? Sure. What value of x do you need to plug into that for it to come out to 0? 3. If you plug in 3, you'll get 0. And then as you start plugging in numbers higher than 3, the range goes up to infinity. Right, so the way we write the range is 0 to infinity. Bracket, because we actually reach 0. Parenthesis on infinity, because you can never reach infinity. Okay, any question on that? Let's try this one. Okay, so that's what shape is that again when it has the exponent of 2? That's a parabola. Okay, this is a parabola that's been shifted, we're going to learn eventually, down 4. That's what the minus 4 does. So normally your parabola would start at the origin. This one won't. It's going to start 4 units lower. What's the domain for that? How far left and right is that graph going to go? Yeah? In which direction?
Up and left and right.
Yeah, it goes infinitely, left and right. Okay, so the domain here is negative infinity to infinity. In other words, there is no restriction on what you plug in for x. You can square any value you want. How about y? Does the graph go infinitely up and down? No. Orlando, what's the restriction on the range?
-4.
Yep, that's the lowest value it ever goes, and it will reach that value when x is 0. And what's the highest it goes? Infinity. So that's my range for that one. Okay. And you can look at other ones, but that's good for that. Okay, so when they ask you to evaluate a function, okay, very simple algebra 1, basically it means plug in the x value, see what you get for y. So like if I ask you to find f of -2, f of 3, all that means I want you to do is take -2, plug it into the function I give you, and tell me the answer. So let's try that. Let's start with f of -2. Okay, how about, Brandon, what's -2 squared?
4.
We get 4 plus 1 gives me 5. Okay, f of 3, you do 3 squared, gives me 9, plus 1 gives me 10. What would I do to find f of a? How would I find f of a? About Samuel?
Would it just be a squared plus 1?
Yeah, you just whatever they tell you to plug in, you just plug it in, but you can't get a numeric answer because I didn't give you a numeric input. Okay? It's just a squared plus 1. And you do the same thing with x minus 3. Be x minus 3 squared plus 1. Okay? What rule do we use to do that out? I'm sure you remember that from Algebra 1. Yeah, some people call it FOIL or the double distributive property. So you'd get x squared minus 6x plus 9 plus 1, so actually plus 10. So x squared minus 6x plus 9 plus 1 gives you plus 10. So that's what it means to evaluate a function. Plug in the value, you see what you get. Sometimes it's numeric. Sometimes it's not. Okay, I showed you this example earlier. Not all equations are functions. Okay, the easy way that we can tell something is not a function from Algebra 1 is the vertical line test. If you draw your picture and a vertical line hits your graph more than once, it's not a function. If you graph the square root function, the positive and the negative part, it would look like this. It would look like a parabola on its side. And I can draw a vertical line and it hits it twice. Okay, so as an example, how about a circle? Would a circle be a function? No, vertical line would hit that more than once. How about this? That's a sine wave or cosine wave. Would that be a function? Okay, does a vertical line hit it more than once?
No, it's a function.
Yeah, that's a function. If you draw vertical lines, they don't hit it more than once. Horizontal line, that's different, but we're not talking about a horizontal line test. It's a vertical line test. Okay. How about a parabola? Function? Yep, horizontal line test, it fails that, but it does pass the vertical line test. Right? So that's how you can tell if something is a function. Okay. All right, so for tonight from page 20, that's a lot of graphing calculators, so there might not be a lot to write down on page 20, but just write down what you can. It's 1 through 10, 18, 21, 29, 32, 38. And then page 30, that's mostly evaluating functions using the vertical line test. That's 1 through 8, 11, 13, 16 to 19, and 24.